All right, composition of functions. So yesterday we did add, subtract, multiply, and divide. So we can also do compositions, which this should be 100% review because I didn't even include the domain on this stuff because it's really kind of out there. So composition of functions. This is another method to combine functions called a composition. Well, when you write an English composition, you compose it using words. When you compose a piece of music, you're putting music together, right, to make a song or whatever. So when you have a composition of functions, you're putting two or more functions together to make a new one. So given f of x and g of x, the composite function is defined as, so it can look like this. F of g of x, it's not the word fog, that's not a 0, it's not an O, it's a tiny little circle, it's not a dot. The dot means multiplication, so it's like an open circle. Okay, so f of g of x, that is the same thing as f of g of x. You could write it either way, they mean the exact same thing, so you can see it either way. Most likely, I will write it the second way when I write it. Otherwise, it totally looks like fog when I write it. Plus, I think that the second way helps it make more sense to you anyway. Because if I said, we want to find f of 5, right? Then you know you're going to put 5 in everywhere you see an x. So if I want f of g of x, then I'm going to put g of x in everywhere I see an x. Like it tells you what goes on the inside. All right, so let's see how this works for these. So the first thing I want is f of g of x. So that is f of g of x. This means the same thing, right? So that means I'm going to take g of x, substitute it in everywhere in f of x that I can. So that's going to equal x squared minus 4 plus 7. I am substituting in something with more than one term, so I put it in parentheses every single time. Do these parentheses really have any effect on what I'm going to do next? No. I mean, they are doing something. They're grouping it, but it really doesn't help me. That actually is a difference of squares. Do I care about that right now? No, I don't, because I'm not trying to factor. So don't factor just because you can. And then this equals x squared plus 3. That is f of g of x. Just like that. Okay. We good on that? All right. So then I have g of f of x. G of f of x. So I'm going to take f of x, put it into g of x. So this gives me x plus 7 squared minus 4. Do these parentheses have any bearing on what I do next? Yes, 100%. They're definitely important. So I have to square that. That is not x squared plus 49. Okay? Even if you don't know what to do next, you need to know you do not just distribute that. It is not x squared plus 49. This is x plus 7 times x plus 7. So there is a pattern to that. I square the first term. It's x squared. I multiply them together and double it. That gives me plus 14x. And I square the last term, plus 49, and then minus 4. So that gives me x squared plus 14x plus 45, and that is equal to g of f of x. Okay. What questions do you have?
So do you not do the x squared plus 49 because it's not a difference of squares, it's a sum?
Well, either way, you don't do that because you can't just distribute this squared. Okay. You're multiplying x plus 7 times x plus 7. Does that make sense? Does that answer a question? You think so? Okay. If I had just 7x and that was squared, that does become 7 squared times x squared. But if I have x plus 7 squared, that does not become x squared plus 7 squared. You can distribute it here because it's all multiplication, but not here. This instead becomes x plus 7 times x plus 7. And then if you need to do it this way and then you FOIL it or whatever, that's fine. I was just using the pattern there. Okay, we good on that? All right, so then let's look at example 2. I've got f of g of x, f of g of x. So take g of x, substituted into f of x, I get 3 minus x over x plus 1. I am subtracting something that has fractions, so besides 4th grade math skills, what do I have to have? Common denominator. So the 3 isn't even a fraction, so to make it a fraction, I'm just going to put it over 1. Okay? Something in a fraction, put it over 1, now it's a fraction. Bam. So my common denominator is x plus 1. So that first fraction has to get multiplied by x plus 1 over x plus 1, so the numerator becomes 3 times x plus 1. The second fraction doesn't have to be multiplied by anything because the denominator is already x plus 1, so that's just minus x. So then the numerator will become 3x plus 3 minus x. So I get 2x plus 3 over x plus 1. That's equal to f of g of x. I cannot reduce that anymore. I cannot cancel x's out or anything like that because there is addition and subtraction there. What I could do, and you may not want to write this down because I don't want it to confuse you if you go back and look at this, but if this was 3x plus 3 over x plus 1, and then I could factor out the 3, and then I get x plus 1 over x plus 1, could I simplify that? Yes, because this is straight up multiplication right here. So so even though there's not parentheses here, it doesn't matter, they're grouped together because it's the denominator. This would just cancel out, and I would end up with 3 because I'm undoing multiplication with division. If I cancel this out here, then I'm undoing addition with division, and that doesn't make any sense. Okay? We good? All right. Then let's look at B. G of f of x. You go ahead and find g of f of x. That's what I got. It would be 4 minus x. Thank you. See it if you're paying attention. Good job. 4 minus x. There we go. Sorry, I was thinking ahead to the next thing I wanted to say, and then I messed that up. All right, so let's talk about, and I know some of you, whether you want to admit it or not, are tempted to cancel out those x's. Okay? You cannot do that because there's addition there. So I want to show you this. Let's pretend like x equals 5. Okay? So if x equals 5 and I substitute it in here, then I would have 3 minus 5 over 4 minus 5. Right? That would be the same thing. So if it was legal for me to cancel these x's out right here, then it should be legal for me to cancel these 5's out right here, and I would end up with 3/4. Make sense? But when I actually do 3 minus 5 over 4 minus 5, that would give me negative 2 over negative 1, and that gives me 2, which is nowhere near 3/4. Because if I cancel this out, I'm undoing subtraction with division. The opposite of subtraction is not division. The opposite of multiplication is division. So you can't divide it out if if you don't have just straight up multiplication. Okay? Does that help? All right. Let's look at number 3. So f of g of x. That means I'm going to take g of x and substitute it in here. So I'm going to get 9 minus 2 times 4x plus 1 cubed. Can I start by doing 9 minus 2 and get 7? No. So I've got 9 minus 2 times whatever that is cubed. So we're going to go over here and cube that. So 4x plus 1 cubed, and again, I don't get to just distribute that cubed. It's going to be 4x plus 1 squared times 4x plus 1. So we know how to square a binomial. It's not by distributing the square. We start by squaring the first term, 16x squared, multiplying these two together and doubling it, plus 8x, squaring the 1. Then I still have to multiply that by 4x plus 1. Okay. So now I'm going to distribute. I'm going to start by taking this 4x and multiplying it by everything in this trinomial. So 4x times 16x squared, 64x cubed, plus 4x times 8x, 32x squared, 4x times 1, 4x. Then I also need to take this 1 and multiply it by everything in here, so that's easy. That gives me plus 16x squared plus 8x plus 1. Then I have to combine my like terms. And when I combine my like terms, when I have this many, I'm going to mark them out as I go so I make sure I don't miss anything, and I don't use anything twice. I only have one cubed term, so that starts with 64x cubed. I have 32x squared and 16x squared, so that's a positive 48x squared. I have a 4x and an 8x, so that's a 12x, and then 1. Okay, we all good on that? All right, so now I substitute that back in right here. And this is 64x cubed plus 48x squared plus 12x plus 1. What's my next step? Distribute, yes. So I've got 9 minus 128. Ooh, that's not a 28. 128x cubed minus 96x squared minus 24x minus 2. So then I just have to clean that up a tiny little bit, and I get that f of g of x equals negative 128x cubed minus 96x squared minus 24x plus 7. That is it. All right. What questions do you have? Anything? All right. If not, then you do B. That's what I got. No, it doesn't matter at all. I just, when I do it like this, because I'm being lazy, because I don't want to rewrite it, so it doesn't matter. Although, had you asked my teachers when I was growing up, it totally mattered. Your variable better be on the left. All that stuff better be on the left, for no good reason. This wasn't really a rule. All right, so is this a difference of cubes? No. Does it kind of look like maybe it could be? Let's pretend like this was 64. If this was 64, then would it be a difference of cubes? Yes. Does that matter right now? No. Because we could factor it, but do we need to? No. So do we? No. Okay? Don't do it just because you can. All right. Let's look at example 4. So I think the composition part, hopefully you kind of get by now, but we're going to work through some of these others to make sure we're not making up math when we use fractions and square roots and all that good kind of stuff. So f of g of x. Take g of x, substitute it in here. So I get the square root of x squared plus 5. I know some of you are very tempted to do something else. Legally, you cannot. All right? You cannot just knock off that square. You can't split the square root. It doesn't work that way. That is all you can do. That is it. This is f of g of x. Okay? All right, so then let's look at g of f of x. So we're going to take f and put it in g, so that means I'm going to have the square root of x plus 5 squared. What is the square root of x plus 5 squared? X plus 5. So this is x plus 5. That equals g of f of x. Okay. What questions do you have? When you introduce the square root. If you decide to take the square root because you're solving something, then that's when you put the plus or minus. If it's already there to begin with, you use whatever's there. And sometimes you might have something that looks like this and it says plus or minus. Then you have to use the plus or minus. Otherwise, you go with what's there. It's a good question. What else you got? Only if you're trying. The reason that you factor is if it straight up says to factor, which we just do that really to practice, or if you're trying to solve it. But we're not trying to solve it. We're trying to come up with an equation. So there's totally no reason to do that. Okay? Good question. What else you got? All right. Let's look at the next one then. All right. So actually, you do A. What's the cube root of x plus 4 cubed? X plus 4. So x plus 4 minus 1. So we get x plus 3. That is f of g of x. We agree with that? All right, you do B. What's the cube root of x cubed plus 3? The exact same. It's the cube root of x cubed plus 3. Just like with the square root, you can't distribute it. That is all you can do. That is g of f of x. Okay. What questions you got on that? We good? Okay, so now we're going to look at evaluating. The word evaluate has the word value in it. So we are going to evaluate. We get a value, like a number, not an equation. So there's a couple different ways you can do this, but if I want f of g of 3, this is f of g of 3. I think that makes it a little more obvious what you're trying to do here. If I want f of 5, I substitute 5 in everywhere I see an x. If I want f of g of 3, I have to know what g of 3 is so I can then go substitute it in. So I'm going to find that first. G of 3 equals 3 plus 1, which is 4. So I've got that. That's g of 3. So f of g of 3, in here I substitute in 4. Absolute value of negative 2 times 4 equals the absolute value of negative 8, which is 8. So f of g of 3 equals 8. Okay, so it's just a two-step, very simple, substitute it in. Not that big of a deal at all. All right? Questions? All right, you do B. $11? Agree with that? Okay, good. All right, we're going to do 7a together because I want to talk about square roots again on part of this. So f of g of 9. So we're going to do g of 9. That is equal to the square root of 9 minus 4, which is the square root of 5. So then f of g of 9 would be the square root of 5 squared plus 5 square root of 5. What's the square root of 5 squared? 5. So f of g of 9 equals 5 plus 5 square roots of 5. Does that become 10 square root of 5? No, because you treat square roots like variables, so that's like 5 plus 5x. Okay, so let's make a little side note here again. So on the front, we had one where we ended up with x squared plus 5. And I know by the looks of what we did on like our last test, some of you really want to do something like with that. You think you should be able to split up that square root or make the square root of x squared just x underneath there because it has a square root. Well, if any of that was legal, then I should be able to do that at this point also. If I have the square root of 9 minus 4, then if I can just take the square root of this, then I should be able to do that here. So then I should be able to say, well, then that's just 3 minus 2, which is 1. But that is not the truth, because the square root of 9 minus 4 is the square root of 5. So again, you're trying to take the square root and split up subtraction. Square root is not the opposite of subtraction. Therefore, you can't split it that way. All right? Does that make sense to you? We good on that? All right. Then you do B. Once you get to the square root of 80, you have to simplify that square root. No calculators. You don't leave it like that. I don't want a decimal. You got to know how to simplify your square root. Okay, so if you were taught to do that, and the only way you know how to do it is to look for the biggest perfect square that divides into that, that is not the best way to do every single problem. And it's not even the best way for some of you to do it at all. If you can look at that and you know what the biggest perfect square is, great. If you have to even think for a second, then you are wasting your time and you just need to do the tree. Okay, so if I have the square root of 80, I do know a perfect square that divides into there, and that's 4. And this would be 4 times 20. So as my branches go, I'm going to stop a branch at a perfect square or a prime number. So this is a perfect square, so I'm going to stop right there. And then I can make this 4 times 5. 5 is a prime number. Okay, and then the 4s, it's a perfect square, but I don't even have to take the square because I have a pair. Because once you get here, you start looking for pairs. I have 2 4s. That just comes out as a regular 4. This guy's by himself. He stays underneath. It's 4 squared, it's a 5. So g of f of 7 equals 4 square root of 5. If you cannot simplify a square root, that's something you need to go practice on your own a lot, because I'm not going to reteach it every time we do it. I'm just going to expect that you can get it. Okay? What question you got? Alrighty. So now we're going to decompose the functions. We've been composing them and putting them together. We're going to decompose them and take them apart. So let's start with this. So it says find 2 functions f and g such that f of g of x equals h of x. So what they're telling us is that f of g of x equals h of x, and f of g of x equals h of x. Okay, these are the exact same things, just however you want to say it. Again, I think this second one is a little more obvious about what's going on the inside. So we have the composed function. We need to figure out what we could use to come up with that. And there's more than one right answer. And we're going to look at more than one answer on each one of these. So for this first one, I'm going to come up with an f of x and a g of x. And we're actually going to come up with 2 different ones that could work, not one right answer here. I think that figuring out a g of x first is easier because it's easier to kind of see what's on the inside. So if I wanted to say, all right, we're going to make g of x 1 minus 2x. If that is g of x, what would f of x have to be? X cubed. Okay, because then you can see if I take this and substitute it in here, that's what I'm going to get. That's what we're trying to get at. Okay, so you kind of work backwards. So if I take g of x and I find f of g of x, I substitute this in here for x, this is what I'm going to end up with. Okay? What if I said g of x is 2x? Then what would f of x have to be? 1 minus x cubed. We agree with that? What questions you got? Yes, ma'am. No, there's no one right answer. I think there's only really 2 here. I mean, you could stretch it and come up with some really off-the-wall things to come up with more. I mean, there's probably an infinite amount of answers, but yeah. And if I asked you to, you wouldn't have to come up with all of them. We're going to come up with a bunch just so you can see that there's different ones. But yeah, your answer could be different than your neighbor's, and you could both be right. Alrighty. Let's look at number 9. So we're going to come up with 2 sets again. So f of x and g of x. And then we'll have a second f of x and g of x. All right, so if I said g of x is equal to x squared plus 1, then what would f of x have to be? Cube root of x, yes. All right, so then I want you to think about what a different one would be. All right, who wants to tell me what they think another one would be? Anybody? What you got? Good. Y'all agree with that? That works, right? Okay, good deal. Any questions? You would only have to put 1, yeah. All right, number 10. I want you to try and come up with at least 1. Try to come up with 2 different ones. I'll give you a minute to do that. All right, who wants to give me one option? Somebody that hadn't given me one. What you got? All right, y'all agree with that? Does that work? Even if that's not the one you wrote down, that one works, so you can write that one down. Anybody have anything different? Nobody? What if I made g of x 4 over x plus 7? Then what's f of x? X minus 1. Good. All right. What questions you got? It would pretty much have to be a variable since we're trying to come up with an equation, because whatever g of x is, you're replacing the x's in f of x with it. And if you don't replace it with something that has an x, you won't end up with any x's in the end. Does that make sense? All right, good question. Anything else? All right. So then on 11, there's multiple ones, but there's 3 basic different ones. So I want you to see if you can come up with at least 2, maybe 3. Okay, somebody that hadn't given me something. Can you give me one? Wait, which one is this? For f. Okay, so say that again.
So 1/2 x.
Okay.
Plus 3.
Uh-huh.
And then for the g is going to be absolute value x plus 5.
Okay, that is so good, and you actually gave me the exact same thing somebody did last period. You're missing a tiny thing on f of x. What are you missing on f of x? The negative. Yeah, okay. It's all good. Very good. Okay, y'all agree with that one? So if you don't have that one written down, write it down. All right. Somebody give me something different. What you got?
F of x equals negative 1/2 x. G of x equals absolute value x plus 5 plus 3.
Okay, what do y'all think about this one? Let's think about this. If we substitute that in, I'll get negative 1. It's okay. I've gotten this one every period too. I get negative 1/2 times the absolute value of x plus 5 plus 3, right? So when I distribute, I get negative 1/2 times the absolute value of x plus 5 minus 3/2, because I'd have to distribute that. Does that make sense? It's okay. I've got it every period, so that's why I said, kind of check yourself. All right, so we're going to take that one off. All right. Anybody give me anything else that they think works? What you got? Oh. No. Tell me. Now you have to speak.
It's the same one as the first one, but like instead of the absolute value being on x plus 5, it's on x.
Oh, that's totally fine. That works. So negative 1/2 times the absolute value of x plus 3, and then x plus 5. That totally works. Is that what you were going to say? Or you have something else? What do you have? It's okay. Give me what you got. Okay. Okay. Y'all agree with that one? That totally works. Now, here's some other options because this is negative. So I could have here, if this was positive 1/2 x plus 3, this could be a negative absolute value, then that would still work. And kind of same thing here, this could be a negative x and make this positive, and then we'll just give you another version of it, but we don't need to write all those down. Okay, we good? You see how that works? Okay. Any questions at all? Awesome.